Okay, so this is question 6. As you can see from the marks, it used to be an exam question, so it's a little bit of a beastie actually. So let's just kind of come up with a plan. So first of all, they want to talk about the normal to the curve, which suggests that we find the equation of the normal. Then we want to talk about whether or not it cuts the curve again. So we're talking about where these two lines intersect. So I want to do some kind of simultaneous equation and find out that it only touches here. So let's have a go, first of all, just finding the normal, so differentiating like we have been doing. Dx by dt is 3 plus 3t squared. dy by dt equals minus 6t. So dy by dx is minus 6t over 3 plus 3t squared, which is minus 2t over 1 plus t squared. Okay, so we want to find the gradient of the curve at this point. The problem we've got here is the coordinate minus 4, 5 are coordinates in terms of x and y, and we've got a function in terms of t. So we need to work out what x and y were. So if we look at this, this is an expression for your x coordinate in terms of your t. So if x was minus 4, there would be a t, so that those would be equal. Don't fancy solving cubic, so I'm going to use the other one first. So I'd also get the same with y. 5 equals 8 minus 3t squared. Rearranging then, 3t squared equals 3. So t is plus or minus 1. It's not going to be both because this is only one distinct coordinate, so let's substitute in here and find out. So if it's plus 1, I get 3 plus 1, which is 4, and 4 doesn't equal minus 4, so it must be minus 1. Okay, so we know our t coordinate, we know our x and y coordinate, we now need our gradient, so we find the equation of the normal. So substituting back in, dy by dx when t is minus 1 is minus 2 times minus 1, so that's plus 2, over 1 plus 1 minus 1 squared, so that's just 1. And that means that the negative reciprocal gradient for the normal then, m is minus 1 over 1, which is minus 1. Okay, getting this normal then, so here's our point, here's our normal gradient, we'd have y minus y1 equals m, x minus x1, so it's x minus minus 4, which is plus 4. So that'd be minus 4 plus 5, which is plus 1. Okay, so we're trying to solve simultaneously where this normal meets this curve. So let's have a think about the best way of doing that. Okay, so the tricky method would be rearrange one of these for t and substitute in to get a Cartesian, and then solve that with this. Sneaky cheat kind of way is, I know y is worth 8 minus 3t squared, so I could pop that in here. X is 3t plus t cubed, so I could pop that in here. And then I'm just going to have a cubic to solve in t. So let's do that. So I've got 8 minus 3t squared equals 3t plus t cubed. So it's minus that plus 1. So it's just substituted into here. Let's tidy that up a bit. Okay, so that's obviously looking pretty nasty, and your first thought is probably, how am I going to solve a cubic? So what we're going to do is we're going to use what we already know, and that's that they already definitely meet when t is minus 1, because that was the t value for this point. So if t equals minus 1, is a root, t plus 1 has to be a factor. So we're going to divide by t plus 1. You could do the grid method. I'm just going to do it in my head, but go crazy. Okay, so definitely t equals -1 as a solution, and we know about that one. What we need to work out is whether or not this has any solutions. I'm going to use the discriminant to find out if it has any solutions first. So b squared minus 4ac would be 16. Take away 4 lots of 1 times 7. So that's 16 minus 28, which is minus 12. So this has no solutions because I can't square root a negative. So as this has no solutions, the only place where the curve and the normal cross is at t equals -1. So we can deduce that it doesn't cross the curve again. And we should write that down. Just for fun, I'm going to hide all my working for this review sheet around the maths department, so if you can find it, it's yours.